For today's lesson, we're going to go ahead and review the triangle sum lesson for 8.1 because we will be moving forward in Unit 4A. So remember at the beginning, we went ahead and we classified our triangles by their sides. We called them scalene if they had no congruent sides. We called them isosceles if they had two congruent sides. And we call them equilateral if they have three congruent sides. Now remember on Alex that if a triangle is equilateral and has three congruent sides, it also has two congruent sides and you can call it isosceles. So remember, an equilateral triangle is also isosceles, but an isosceles is not also an equilateral. All right, then we went ahead and we classified by our angles, And we can call them acute, obtuse, right, or equal angular. They're acute when we have three acute angles. Remember, an acute angle is an angle that is under 90 degrees, but bigger than 0. So all three of them need to be under 90, but of course bigger than 0. For a triangle to be obtuse, we can only have one obtuse angle. Think about it this way. Remember, a triangle can only add up to 180, which is what we're going to talk about next. So if I have a triangle, if I have two angles that are, say, both 100, when I add them together, I have 200. That is not a triangle. It's already too big. So I can only have one. For a right triangle, I have one right angle. And remember, a right angle is 90 degrees. And a lot of time in geometry, I let you know that you have a right angle by using the box in the corner. It's just a way to try to trick you because I can't do it very often. And of course, equal angular, we call them when we have three congruent angles. We didn't talk about that on Alex, but just for your information, I call a triangle equal angular when it has three congruent angles. All right, let's go ahead and go over the triangle sum theorem again. It says the three interior angles of a triangle sum to 180 degrees. So here's my triangle, and I have my angles labeled 1, 2, and 3. What this theorem basically says is that whatever the measure of angle 1 is, I'm going to add it to the measure of whatever angle 2 is, and then I'm going to add the measure of angle 3, and I get 180. Okay, angle 1 plus angle 2 plus angle 3 equals 180 degrees. Let's see how we can use that in a problem, how we can apply this theorem. So here's my triangle ABC, and they want me to find the value of x. Since all of my angles are inside, if I were to label them like we did in the theorem 1, 2, 3, I can see that I can quickly apply the theorem and say angle 1 plus angle 2 plus angle 3 equals 180 degrees. So I'm going to go ahead and do that. So 10x minus 1 plus 18x plus 2 plus 15x plus 7 equals 180 degrees. Notice what I've gone ahead and done is I've gone ahead and dropped my parentheses. I've spaced them out a little bit more for you so you could kind of see them. But I've gone ahead and dropped the parentheses, and I've dropped the degree sign because this is not an exponent, this is the degree symbol, so it doesn't have to be in my equation. All right, now I'm just going to solve like I would any math equation by combining together my like terms. So let's add all the x's up. So 10x plus 18x plus 15x would give me 43x. And let's go ahead and combine all our constants. -1 plus 2 plus 7. That would give me +8. And of course, that equals 180. Now I have my equation to solve, and I'm just going to slide up one last time. Yep, they just want me to solve for x. So I'm going to go ahead and subtract my 8. which gives me 43x equals 172. I'm going to go ahead and divide by 43. X equals 4. Okay, now don't forget that I could go ahead and add that 90 degrees, and I know that Alex does that. Remember, if I were to change any of these angles here, here, or here to 90 degrees to try to trick you, I could just put the box in the corner. And in the instructions of the question right up here, I could tell you that angle C is a right angle. All right. The next thing we talked about in this lesson was the exterior angle theorem. And this says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay, let's go ahead and start with what's exterior and what's interior. Well, angle 4 out here would be considered exterior because it is outside of the triangle, which means all of these angles inside would be 1, 2, and 3 would be considered interior. That's the first thing that you need to understand. What am I talking about when I'm talking about exterior versus interior? All right. Now, what I'm going to do is I'm going to go ahead and derive this theorem that says it's the exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. That's kind of a little tricky. So let's go ahead and just take a look at our exterior angle, angle 4, and let's compare it to angle 3. These two angles together create this straight line, which I know is 180 degrees. So I can say that the measure of angle 3, or angle 3, plus the measure of angle 4, angle 4, equals 180 degrees because I know that they are a linear pair. They create that straight line. I also know that angles 1, 2, and 3 together create a triangle. So as per the last theorem, I could go ahead and say angle 1 plus angle 2 plus angle 3 equals 180 degrees. That's the triangle sum theorem. Okay, now what I'm seeing is that I have two equations that are both equal to 180 degrees. 180 is equal to 180. So that means I can set the other two parts equal to each other. This is the transitive property. If we are equal to the same thing, then we are equal to each other. The transitive property says this is true. These two are equal to each other. This is equal to this, right? Because they are both equal to 180, the transitive property. Now, if I take a look at my two equations, there's something that matches. There it is. Notice that on both sides, I have an angle 3. I can go ahead and move one of them to the other side by subtracting. But if I do that, oops, there we go, they cancel out on both sides, leaving me with angle 1 plus angle 2 is equal to angle 4. And this right here, ladies and gentlemen, this is what the theorem is saying. The sum of the two non-adjacent interior angles, that would be angle 1 and angle 2, is equal to the exterior angle. Okay, so to find this angle, all I have to do is say this one plus this one equals that one. Okay, I only need 3 so that I can cancel it out and not use it. So I find the exterior, the one inside I don't use, and I add those together to get 4. Okay, that's what the theorem is saying. Let's go ahead and apply it, and then we'll be done with our review. So here's my example 2. Find the value of x. So I just have to go ahead and look, where's my exterior, where's my interior? Well, here's my exterior, here's my interior. Okay, my exterior angle, I'm going to call it angle 4, and I'm going to call the one right inside next to it angle 3, and I'm going to go ahead and call them 2 and 1, and it doesn't matter which way I put 1 and which one I put as 2. Remember, we cancel out the 3. We're not going to use it. The rule says, the theorem says, angle 1 plus angle 2 equals angle 4. That's what the theorem says. Angle 1 plus angle 2 equals angle 4. Okay, the two insides added together equals the outside. Now, this one is an equation. I do believe in Alex, you just went ahead and you had numbers and you either had to add or subtract. Here, I'm going to actually have to do some math. So I'm just combining together my like terms, my x with my x, my constant with my constant. Just remember that both of my constants were negative, and so that's why I got a negative 10. And divide by 10, x equals, oops, I put a 15. That's not right. Divide by 10, x equals 15. There we go. And that's all we were asked to solve for, right? Yes, that's all we were asked to solve for. All right, see you guys next time.